Please title these notes Derivatives 12 Notes, Quotient and Chain Rules, and write today's date. By the end of this lesson, quotient or chain rule, even if you don't know which one's going to be coming up. And you should also be able to work with them if there are multiple ones in the same problem. So for starters, let's just practice figuring out which is which. Let's look at this problem. Let's find the derivative of sine x over 3x. Are we going to use the product rule, the quotient rule, or the chain rule? Well, we have so division automatically means the quotient rule. So let's just go ahead, label this quotient. Basically here we've got this f. Here we've got a g. So we're going to use the quotient rule. Derivative of f of x over g of x is f prime g minus fg prime over g squared. Go ahead and go for that. So we've got the derivative of sine of x times 3x minus sine of x times the derivative of 3x all over 3x squared. The derivative of the sine of x is cosine of x times 3x minus sine x, then the derivative of 3x is 3. Ooh, bad mistake there. This whole denominator should be squared. It should be a whole thing 3x squared. Okay, with these problems, you should simplify at the end because typically you're going to see your answer choices in simplified form. So we notice that there's a 3 in both of these, so we can factor out a 3 in the numerator. Notice this cosine of x and sine of x, the x's are attached to the sine and cosine, so we can't factor out an x. This x from right here is still there though. Notice here as well, this is 3 squared and x squared. This and this can cancel out. And there we go. The quotient rule is pretty easy to see, but sometimes the product rule and the chain rule are hard to tell apart. So let's look at this one. Derivative of e to the 3x squared. Notice that right here, this is a box function. Box function automatically means we're going to have a chain rule. So the derivative of e to the box is going to be e to the box times the derivative of the box. So this is e to the box, which is 3x squared, times the derivative of the box. 3 is the long, times 3 is the long for the ride. Bring the 2 down, subtract 1 from the exponent, so that's 2x to the first power, or e to the 3x squared times 6x. The final one, I bet you can guess what it's going to be since there's only one left, but it's still important to be able to tell it apart from the other ones. So let's take the derivative of 7x, natural log of x. Notice we do have a box function here, but there's only x in it, so we don't need to use the chain rule. Notice in particular that these are really multiplied together, so here we've got an f, here we've got a g, and it's a chain rule, or excuse me, a product rule. F times Derivative of f times g is going to be f prime plus fg prime. So derivative of the first times the second plus the first times the derivative of the second. Derivative of 7x is 7. The derivative of the natural log is 1 over x. Those x's cancel out nicely. We're left with 7 natural log of x plus 7. Those 7's can be factored out. Right like that. Now let's Here are the steps to help you keep oriented. First thing we're going to do, rewrite the problem. If it's needed. Sometimes you don't have to. Second, we're going to identify and apply any product or quotient rules. Then we're going to take each derivative one at a time, then simplify. And for these middle two steps, you should write the formulas on the side. Make sure that you write those formulas just because of that way it makes things a lot clearer. You're not sort of searching your memory so much. Okay, let's do some examples. Let's find f prime of x if f of x equals 3x sine squared of x. Notice when we see this sine squared, we know from earlier that this really means sine of x squared. So this is where the rewrite step comes in. Notice this is still f of x, but I'm going to rewrite this as sine of x squared because now I can clearly see the box function here. Before I get to my box function though, I want to look for any product or quotient rules. Notice I see this multiplication right here, 3x times sine of x squared. So that means that I've got two different functions here. And under my formulas, I want to write the product rule. Product meaning multiply. Okay, now I'm going to start taking the derivative. So keeping careful track of what I'm working with at each stage. I'm going to apply my product rule. F prime g plus f g prime. Now, people really like to do a bunch of work in their head because it takes a lot of writing for all the successive steps. I'm going to show you a way that's okay to do where you're showing out all your work, but it's not as much writing for you. So what I want you to do is I want you to take each derivative separately. So show right here what you're taking the derivative of, and there we go. So you didn't have to write out all these steps. We're just doing this, and then we're going to put them back in just a second. Same thing over here. Notice, however, that right here we have a box function. So that means I'm going to need another formula. The derivative of box squared is 2 box, derivative of the box. I'm going to apply that right here, so it's 2 box, which is sine x, times the derivative of sine of x. Derivative of sine of x is cosine of x, right there. So now these can go right back in the equation. I'm going to write f prime of x again down here. And it's very, very important, make sure you get all the little pieces. So this whole thing became 3. We still have this sine of x squared there. This 3x is still there. But this whole thing that I underlined in red became 2 sine x cosine x. If you are having trouble losing pieces, you can also put actual full box around these so that you can see what you've worked with and what you haven't. I like the little underlining myself, but make sure that you have all your pieces at the end here. None of them have gotten lost. For these examples, we want to simplify them. That means we should factor out anything that we can factor out. So I see a 3 and a sine of x in each. In fact, there are 2 sine of x's here. That means I can factor out 3 sine x. There's 1 sine of x left over. There's an x and a 2 and a cosine of x. Right there. Our second is similar, but it involves a little different simplification at the end. F of x equals e to the 2x times the square root of 5x squared minus 3. Notice whenever you're dealing with a square root like this, it is extremely important to do that rewrite step. So I haven't taken the derivative yet. It says e to the 2x times 5x squared minus 3 to the 1/2 power. So first thing we do is we look for product and quotient. We can see there are 2 pieces multiplied together. So the derivative of f times g is f prime g plus fg prime. So let's start with that. We're taking that derivative. Derivative of e to the 2x. This stays put. And then e to the 2x times the derivative 5x squared minus 3 to the 1/2 power. Now we can work those 2 out separately. Notice here we have a box function, so that means we're going to need to use the formula. Derivative of e to the box is e to the box times the derivative of the box. E to the box times the derivative of the box. Okay. Whereas over here, let's write our formula. The derivative of box to the 1/2 is 1/2 box to the negative 1/2 times the derivative of the box. So we've got 1/2 5x squared minus 3 to the negative 1/2 times the derivative of 5x squared minus 3. So this part's done now. We can rewrite it as 1 over 2. This is a negative exponent, so it's in the denominator, 5x squared minus 3. And then the derivative of 5x squared is 5 times 2x. Derivative of negative 3 is 0, so it just goes away. These 2's cancel right out. We have 5 over square root 5x squared minus 3. So we can go ahead and put all that back in the f prime equation. 2e to the 2x. This can go back to being a square root 5x squared minus 3 plus e to the 2x times 5 over square root 5x squared minus 3. Now notice with simplification, if we have a rational expression like this right here, then we want to get common denominators and put them all together. So that means that this, since it's our only denominator, is going to be our common denominator. Giant 1, square root 5x squared minus 3 over 5x squared minus 3, 2e to the 2x square root 5x squared minus 3 all over 1. And then these can just come together, 5e to the 2x over square root 5x squared minus 3. Right, like that. Now notice that this times this becomes the square root of something squared. So when these two are multiplied together, that means the little square root just goes away. We have 2e to the 2x, 5x squared minus 3. This is all over our common denominator. Notice that in calculus, having a square root in the denominator is just fine, because otherwise it's a huge pain in the neck. And again, we have this little e to the 2x that's in both, so we can factor that out. And the final step is to simplify that last little bit. Oh, whoops, it looks like something got away from me. It looks like I lost the x up here. There should be an x right here, and that means that there's going to be an x right here, and right there, and right there, and right here as well. So then when I distribute this 2 and simplify everything, we're going to get 10x squared minus 6, and that 5x is going to go right between them, right in there like that. Let's do another example involving the quotient rule. Find f prime of x if f of x equals the natural log of x. Actually, let's make that the natural log of 5x over 2x plus 4. Now we can pretty clearly see that two things are being divided, so for our formulas, we're going to have the quotient rule, f prime g minus fg prime over g squared, right like that. There's no rewriting that needs to be done, so we can jump right into taking the derivative. We're going to have the derivative of the natural log of 5x, 2x plus 4, minus the natural log of 5x, times the derivative of 2x plus 4. And remember, that's all over 2x plus 4 squared. Don't forget that denominator part. So we can still split these up and work with them separately. So the derivative of the natural log of 5x, notice right there we have a box function. So that means one of our formulas is the derivative of the natural log of the box is 1 over box times the derivative of the box. So let's do that. 1 over 5x times the derivative of 5x, that's 1 over 5x, times 5. The 5's cancel right out, just leaving us with 1 over x. Over here, derivative of 2x plus 4 is 2, and that's all there is to it. Okay, f prime of x, so right here we have 1 over x times 2x plus 4 minus the natural log of 5x times 2, all of that over 2x plus 4 squared. Now notice that we have a denominator here, So this is a rational function. We're going to want to take these two and subtract them. So that means we have to get common denominators over here. Don't forget that little denominator. So these are going to get multiplied together. The whole numerator has the denominator of x. So we've got 2x plus 4 here minus natural log of 5x times 2x. Now this, we can think of this as being over 1. That's going to make it possible for us to simplify it. So this numerator is 2x plus 4 minus 2x natural log 5x. Notice that we can't factor out a 2x because there isn't an x here. However, there is a 2 in every single term, so we will be able to factor that out when we get there. Dividing by a fraction is the same as multiplying by the reciprocal. So we'll factor out that 2. That's x plus 2 minus x natural log of 5x all over x times 2x plus 4 squared. This method also works fine for triple chain rule problems. It's just that it's really easy to lose pieces on a triple chain rule. And so for that reason, I recommend doing out the entire problem by rewriting each step. So let's look at this. Let's find f prime of x if f of x equals secant squared of x to the 5th. This one does require a rewrite. When we see this, we want to make sure to rewrite it as secant of x to the 5th quantity squared. And now there's no multiplication or division here. It's just a whole bunch of chain rules. So we can just do our little chain rules. We can also see that we're going to have secant, so we might as well write that rule out while we're at it. And that is secant box tangent box times the derivative of the box. So for f prime of x, we'll do the derivative of the outside, so that's 2 box times the derivative Notice that here we've got that box function again. So the derivative of secant box is secant box tangent box. Times the derivative of the box. Because it's so easy to lose these pieces, I recommend bringing them all down. Secant of something times secant of the same thing is secant squared. This is 5x to the 4th. This and this can be multiplied together. And there we go. Okay, let's give you a check for understanding problem. Find f prime of x if f of x equals e to the 3x over x squared plus 4. Go ahead, pause the video and do that on your own. Make sure to do your chain rule when needed. Start the video again when you're ready. Okay, this is what I have for this one. So we're definitely going to use the quotient rule. So here's the first step with the quotient rule. And then I separated out my derivatives to do them each separately. Merged them back in. Factored out the e to the 3x. Distributed this 3 to get 3x squared plus 12 minus 2x. Just wrote it in the standard order, and I kept that denominator all the way through. The final piece I want to point out to you is that we can also do this with evaluating. So let's find f prime of 0. Notice this is different now. This means plug in 0 at the end. If f of x equals e to the 2x times the sine of x. So we can see that this is our product rule. We can see also that we've got a little box function right there, so we will be using again the derivative of e to the box is e to the box times the derivative of the box. So let's start with taking that derivative and using that product rule. Derivative of e to the 2x times the sine of x plus e to the 2x times the derivative of the sine of x. Let's work these out separately. That's still going to be e to the 2x times the derivative of 2x. Derivative of sine x is just cosine of x, so we don't need to work that one out, although you can if you want. Now, notice up here this says f prime of 0, so that means to find f prime of 0, we need to plug 0 in. E to the 2 times 0 times the sine of 0 plus e to the 2 times 0 times the cosine of 0. Now, for evaluating trigonometric functions, 0 is right there. It's at the point 1 comma 0. X is the cosine, y is the sine. So what that means, e to the 2 times 0 is e to the 0. Anything to the 0 power is 1. Sine of 0 is 0. E to the 0 is 1. Cosine of 0 is 1. 2 times 1 times 0 is 0. 1 times 1 is 1. 0 plus 1 is 1. Right like that. Okay, let's do a last check for understanding problem, and then we'll be all set. So right there, if f of x equals 2x to the 5th plus 3 over e to the 2x, find f prime of 0. Pause the video, restart it when you're done. Okay, so this is what I got for this one. I can see again that it's going to be a quotient rule, so that means I'm using the f prime g minus fg prime over g squared. So I wrote this out, the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Then I went and I worked out the two derivatives separately. I got 10x to the 4th here, e to the 2x times 2 over here, there's that 2 times e to the 2x. There's that original piece. There's that original piece. There's this derivative. And I know that the power rule for exponents means we just multiply exponents. So this is e to the 4x. Now, having found that, I can just simplify 0 in right now. So this is 0 to the 4th. Actually, it doesn't matter. Anything else that's in here, that's automatically going to be 0. Here, put 0 to the 5th in. That's 2 times 0. 2 times 0 plus 3, that's 3. 3 times 2, and then e to the 0 power is 1. E to the 0 power, still 1. And then when I put this all together, I get f prime of 0 is -6. That concludes these notes.